Have you ever wondered why some huge, expensive software projects just work perfectly, while others turn into these legendary, catastrophic failures? Well, it almost always comes down to getting the very first step right. So today, let's dive into the discipline that really separates success from disaster: systems analysis. This cartoon just nails it. It perfectly captures why so many new business software projects fail. It almost always boils down to a simple communication breakdown right at the very beginning. A user knows exactly what they need, but somewhere along the way, that need gets twisted, misunderstood, or just plain lost in translation. So what ends up getting built is, well, not what anyone actually wanted. And look, this isn't a coding problem, it's a communication problem. And this gap, it's not just frustrating, it is incredibly expensive. We're talking about so much wasted time, completely blown budgets, and just a ton of aggravation for every single person involved. The thing is, when people are unhappy with their new information systems, you can almost always trace it back to this moment, the requirements being misinterpreted from day one. But there is a specific discipline designed to stop this from ever happening.
And that's where our hero comes in: systems analysis. This is the process that literally acts as a bridge across that massive communication gap. Its entire reason for being is to make sure that before anyone writes a single line of code, we are all absolutely certain we're building the right thing.
So what is it really? Well, you can think of systems analysis as the investigation phase. It's all about playing detective to figure out what the new system needs to do. Notice I said what, not how. At this stage, we are laser-focused on defining the problem, not jumping ahead to design the solution.
And this right here, this is probably the most crucial point to understand: the difference between analysis and design. Analysis is all about the what. What are the business rules? What kind of data do we need to track? What is the user actually trying to accomplish? Then, and only then, comes design, which is the how. How are we going to build the database? How will the user interface look and feel? You see, you simply can't design a brilliant solution if you haven't first accurately defined the problem.
And when you boil it all down, the whole analysis process really stands on two pillars. First, you've got fact-finding. This is the detective work we talked about, digging in to uncover what people really need. And second, you have documentation. This is where you take everything you've learned and turn it into a crystal-clear blueprint that everyone on the project can understand and follow.
All right, so let's dig into that first pillar, the investigation. This is where the systems analyst really puts on their detective hat. The main goal here is to gather clues from all over the business to piece together a totally complete picture of what this new system needs to do. And analysts have a whole toolkit for this job. This is not a passive activity at all. I mean, they're out there interviewing users to get their direct input. They're digging through old manuals and forms. They're actually watching people do their jobs to see the process in action, sending out questionnaires to get a wider range of feedback, and even facilitating brainstorming sessions to dream up entirely new ways to solve a problem.
Now, interviewing. That's the most popular technique by far, and for good reason. It's amazing for getting that rich, detailed, honest information. Those little insights that you'd never get from a form. But you got to be careful. The analyst's own biases can accidentally shape the answers. And sometimes employees might feel a little defensive or threatened by change. It really is a skill to do it right.
Okay, so the detective work is done. You've interviewed, you've observed, you've collected all the facts. Now comes, arguably, the most critical part of the whole process: turning that mountain of information into a clear, precise blueprint that the designers and developers can actually use to build something. And that official blueprint has a name: the requirement specification. Honestly, the best way to think about this document is as the contract for the entire project. It describes in painstaking detail what the software must do, the data it handles, how the screens should work, everything. It becomes the single source of truth that everyone refers back to. To make this blueprint easy to understand, analysts use a few different kinds of diagrams. The first one is the information flow diagram, or IFD. Think of this as the 30,000-foot view. It's a super simple map that just shows how a piece of information, like a new sales order, moves from one department to another, say from sales over to accounting.
Okay, so from that big picture, we zoom in a bit with a data flow diagram, or DFD. This diagram is brilliant because it shows the actions or the processes that actually change the data. For instance, it would show a process bubble called check customer credit, and you'd see exactly what data flows in and what decision flows out. It's all about the verbs.
And finally, there's the entity relationship diagram, or ERD. This one gives us a view that's totally focused on the data itself. It identifies the key things or entities that the business cares about, like customers, products, and orders, and then it maps out the relationships between them. For example, it'll show that one customer can place many orders. It's the skeleton of the database.
So let's tie this all together and go back to where we started. We've done our investigation, we've created this detailed blueprint with all these diagrams and specs. How does all this work actually prevent that tree swing disaster from happening?
Well, it's actually pretty simple. A really solid analysis phase creates a shared understanding for everyone. The diagrams and the specifications become a common language. A user can look at a diagram and say, yes, that's exactly what I mean. And a developer can look at that same diagram and know precisely what they need to build. Everybody is finally on the same page, working from the same set of plans.
And here is the real bottom line, the number that should get everyone's attention. The source material makes it clear. Fixing an error after the analysis phase is done can cost more than 10 times as much as fixing it during analysis. Think about it. Catching a misunderstanding on a diagram is cheap. You just erase a line. Ripping out and rebuilding a core feature after it's already been coded, that is incredibly painful and expensive.
So, what's the key takeaway here? It's that taking the time to do a proper systems analysis isn't some kind of delay to the real work. It's an investment. It's what prevents all that costly rework down the line. It aligns the entire team around one clear goal. And most importantly, it makes sure you're solving the right problem from the absolute beginning.
So the next time you're using a piece of software at work and you find yourself getting frustrated because it feels clunky or it just doesn't seem to do what you think it should, just pause and ask yourself this question. Was it really a bug in the code? Or is it possible that the blueprint itself was just wrong from the very start?